Hello everyone. This video will be on the 3.12 section of the IBAA curriculum. Please pause the video for a second to look at the concepts, contents, and formulae for this section. One sentence that summarizes this section is vector is a property that is composed of direction and magnitude. Alright, so we're starting a brand new topic that I assume most students have never heard of until this point in life. Welcome. In this topic, you'll be introduced to a new way to view this world. Aren't you excited about it? Anyways, so let's talk about a vector. What is a vector? Well, a vector is a tool that we use to explain a direction and the magnitude. Imagine you're helping a random person on the street how to get to the nearest station. You would usually go with something like you go 2 blocks straight down, turn right, then walk 3 more blocks and you'll see it. Well, with the help of vectors, we can go a lot easier. We can simply say 3i plus 2j. Well, what does that mean? 3i plus 2j tells the direction and the magnitude at the same time. Let's draw out the direction first. 3i, and I here is called a base vector. This vector I tells us that we go one step to the positive x direction. So 3i would be 3 steps to the positive x direction. Similarly, 2j means that we're going 2 steps to the positive y direction, since j is another base vector that tells us to go 1 step to the positive y direction. So at the end, we know that the overall vector starting from this point, ending up in this point. And we can say, oh, that's 3i plus 2j. Right? Then what about the magnitude? Magnitude tells us the total distance. So how far do I have to move? We actually don't have to move 3 steps and then go 2 steps. We can move across the blocks. Therefore, we always walk in a straight line in the shortest distance possible. You'll see here that obviously the magnitude of this vector can be found using our old-time favorite, Pythagorean theorem. The formula can be found in the formula booklet as well, so make sure that you refer to it at all times. Alright, so let's find out the magnitude of this vector. Well, it'll be square root of 3 squared plus 2 squared, 9 plus 4, so we get the square root of 13. I gave you a 2D example to make it easier to understand, but actually in IB, we're going to mainly talk about the 3D context. Therefore, we need to add another dimension using z. And the base vector for positive z direction is k. Okay. So let's say that we need to go down 2 floors to reach the station. Then we can add negative 2k in this situation, probably something like that, to represent that we're going 2 steps downwards. These vectors can be represented in multiple ways, either using the big bracket and 3 numbers listed vertically, or using the base vectors and putting them in additions. So here you'll see the examples on the sides. This is an example with brackets with numbers listed vertically, and this is an example with the additions. Okay. In this case, our vector can be represented as maybe, let's say, u. A u vector has the x component of 3, the second one is y component of 2, last one is the negative 2. Or we can write it as 3i plus 2j minus 2k like we did before. Let's focus on the addition method of the representation because it is going to help us in our next section where we do vector algebra. What happens when we add or multiply vectors? Well, believe it or not, we have already done it. Let's take out the station example that I gave you. I told you that the base vectors are I, j, and k. We have written as 3i plus 2j minus 2k. Well, that's already it. We can simply add the vectors according to the right components. Okay, so actually, I, j, and k, I can write them as something like this. 1, 0, 0. So it's 1 unit to the positive x directions and nothing else. J is 0, 1, 0 similarly, and k is 0, 0, 1. So when we add vectors, we have to add the same components, right? X components with the x components, y components with the y components, and such. Okay. So let's do an example. Let's have our u vector and let's introduce another vector. Let's say v equals to 10, -5, and 0. And let's try to do u plus v. Well, I know u was, in our example, it was 3, 2, -2. So let's write that, 3, 2, -2. Plus v was 10, -5, and 0. Well, I know that 3 plus 10, so I'm adding one of the same components. 3 plus 10 is 13. 2 plus -5 is -3. -2 plus 0 is -2. So we know that u plus v is 13, -3, and -2. If you want, we can look at it using the addition methods. Let's say 3, 2, and -2 was 3i plus 2j minus 2k. And then the next one is 10i minus 5j plus 0k. And then we can simply collect like terms. 3i plus 10i was 13i. And then 2j minus 5j was the negative, minus 3j. And lastly, minus 2k. What if we're trying to subtract two vectors? At this point, we can talk about the vector a negative v. Remember how 2 minus 3 is same as 2 plus -3? We'll do just that using the vectors. When you do negative v, we simply change the signs of all the components. So in our example, negative v would be everything flipped. So 10 becomes -10, -5 becomes +5, and 0 is 0. Okay, so let's do an example of u minus v. Well, u minus v, I can write it as u plus negative v. So let's do that. 3, 2, -2 plus -10, 5, and 0. So essentially we're doing the same thing, except we just have to switch the signs. -7, 7, and -2. Multiplication, we already did it too by doing 3i. For example, when we did 3 times i, well, what we're doing here is we're multiplying a scalar with a vector. So what is a scalar? A scalar is any number that we've been using, such as 2, 3, and they're just numbers, not vectors. Okay, so we call them scalars. So here in this case, 3 is a scalar, I is a vector. So when you multiply a scalar with a vector, we simply multiply the scalar to each component of the vector. So 3 times I becomes 3 times 1 for the x component, which is 3, 3 times 0, 3 times 0. So it becomes 3, 0, 0. So let's take our v again for example. Let's say we're trying to do 2v. Well, 2v is 2 times +10, -5, and 0. So we simply multiply that to each term, each component. 2 times 10 is 20. 2 times -5 is -10. 2 times 0 is 0. So we know that 2v is the same as 20, -10, and 0. Lastly, we'll talk about the unit vector. A unit vector, like a unit circle in the trigonometry, is a vector that has a magnitude of 1. How do we find it? Well, we know that any vector has a magnitude of some values, so we can simply divide the vector by the magnitude. So we get the overall vector as magnitude of 1. For example, our vector v has a magnitude. Let's try to find the magnitude of v. Remember that we have the formula above, magnitude of a vector. Let's use that. And we're going to use this notation, 2 vertical lines, to represent the magnitude. Okay. So magnitude of v, well, we know that this is 10 squared plus -5 squared plus 0. That's 100 plus 25, so we know that's square root of 125. Okay, so to find the unit vector, we need to multiply our v with a scalar value. We're going to multiply that by a reciprocal of our magnitude. Okay, so now this becomes 10, -5, 0 times 1 over square root of 125. And let's do the same thing that we've done for 2v. This will become 10 over square root of 125, -2 over square root of 125, and 0. Okay, and let's just Let's just make sure that this is actually a unit vector. Well, you can find the magnitude of this by using the formula again. 10 over 125 squared plus negative 5 over square root 125 squared plus 0 squared. Well, we know that 10 squared is 100, 125 squared is 125, plus 25 over 125, everything square rooted, so we know that the magnitude is 1. So we know that we found the unit vector. The other topics that I've mentioned before will be discussed more in the following videos. Lastly, let's try an example. Let's say we have a vector named A, where we have 1, 2, and 3. And let's say we have a vector B. Let's write it differently. Let's say negative 2i plus 3j plus 5k. Okay. And let's find the unit vector. Find the unit vector of A minus 2b. Okay. Using 3 sig figs. Right. The answer maybe you'll find in other people's comments. I hope you enjoyed this video and try some questions in this section to really master the skills that we have learned. Anyways, I'll see you in the next video. Best wishes.